Well, good afternoon to everyone who's watching and tuning in to yet another Kepler Live. And we have with us today uh, Mr. Joseph Ahern, who is an astronomy teacher with us this fall, and is actually here in the same town where I am. I'm in Moscow, Idaho, and he's at the University of Idaho getting his doctorate in physics. Okay, well, welcome. Thanks for being here with us.
Yeah, thanks for having me.
And I would love to actually, I gave a little bit of cursory background, but who are you? Where do you hail from? And where go you?
Good question. Yeah, I'm originally from the Chicago area. I decided when I was 14 to start discerning the priesthood in a minor seminary. And so I went away to New Hampshire for that. I continued on for a number of years later. I did a couple of years of novitiate in Monterrey, Mexico. I did a couple of years of humanities studies in Cheshire, Connecticut, a couple of years of philosophy studies in Rome, Italy, then came back to the US, worked with youth for a year in the DC area, then went back to Connecticut and taught humanities classes there, Latin, Greek, physics, geometry, and world history. And that's the year I loved teaching, but that's the year I realized that the priesthood was not going to be for me. So I discerned out through prayer, and I went back to my parents' house in Chicago area. I did a physics degree then at the University of Illinois at Urbana-Champaign, physics and philosophy, double major, and then I have come to the University of Idaho for grad school to get my doctorate. I've been here for about 4 years now.
Okay. And it's interesting that you mentioned this double major, physics and philosophy. And your course that you're offering this coming fall, it's a semester-long course, Astronomy. It is simply titled. You say in your course description that students will be helped in their understanding of the relationships between science, faith, and philosophy. So why is this a particular concern for you that this be able to be found?
It's important when we study anything to have a perspective of the whole. And a lot of times when we study a science, we only study it from the scientific point of view, especially in colleges today. But there's so much history with astronomy, and a lot of it comes from philosophy and theology. And so it's important to understand those perspectives as well. They're often left out in public colleges. And so we need to have contact with those authors of several centuries ago. And so in my course, you're able to get both. The first half of the course is from a chronological perspective or historical perspective, going through history and understanding the universe as people understood it through history. And then in the second half of the course, it's a systematic approach, just going from what's close to us to what's further away from us, and how we understand things today. So it's a view of the whole from the different perspectives. So it seems more complete to me to present it in that way.
Yeah, and actually, I mean, that sort of approach would have been normative not many years ago. This total isolation of disciplines that we have is, well, certainly if you're thinking of educating young men and women, it's disappointing. The idea that you would, I don't know if you would say that this particular way of expressing it is fair, but it seems to me that so much of science now, science, is less about thinking and more about manipulating. Right? So you learn to use information, but there's no philosophy behind that. Is that a fair way of expressing it, or am I being too humanities oriented in that?
Well, it depends really on the scientist. And one problem is that in order to live a life as a scientist, you need to be publishing papers, producing results, and if you try to do some research and you get a negative result, is it worth publishing a negative result? Or do you just try to, publish whatever, make something up so that it catches more attention? And that has happened with some scientists, unfortunately. But that's not the way for us to progress as a species in science. So there should be a better way. We have to do what we can with today, but if we have a strong morals, strong ethical approach, then we're not going to make stuff up, and we're not going to trick anyone.
Right. So philosophy becomes important.
Yeah.
Now, you have this background, you were interested in the priesthood, and you dedicated a significant portion of your life to exploring with seriousness and earnestness that potential calling. But as you did that, you studied and you taught. Clearly, you're enthusiastic for the humanities, and you chose to study physics. So your enthusiasm must be even greater, right?
Yeah.
So you sent me a list of a bunch of stuff that you thought could be cool to talk about. So I'd love to just kind of crank our way through a bunch of this and just start talking astronomy.
Sure.
Okay, cool. So one of the first things you mentioned was your experience during the total solar eclipse of 2017, which was a great Facebook moment for many of us, wearing those the little nifty shades and taking pictures of ourselves out there. And anyway, what was that experience like for you, being, I guess, more in that world?
Yeah. I was blessed, especially because the eclipse was just passing through, the total eclipse passing through southern Idaho. So I was able to get down there a couple of days ahead of time. We were worried that there were going to be tons and tons of people. We beat all the crowds, camped out on free public land for a couple of days. I had spent like the weekends from the past 2 months before the eclipse setting up experiments I wanted to run during the eclipse. So it wasn't a ton of stuff, but I built a solar filter for a pair of astronomical binoculars that I have. I just used one of the sides of the binoculars. I set up a sheet on the ground. So I had 2 cameras, one going through solar filter in the binoculars, one going through actually, you know what? It was not the binoculars. I was remembering incorrectly. It was a DSLR camera, and I had bought a filter. It's a fixed filter. It doesn't zoom in or out, and it's only good for like the moon and the sun, like that type of object. So I built the solar filter for that, and then I had one camera there, one camera looking at the sheet in the foreground, a white sheet, and then in the background was the horizon. And so I have a YouTube video where you can see both of these streams. It's just like I haven't made a lot of YouTube videos, so it doesn't have high quality production, but you can see what it's like for someone who's there. And of course, it's nothing like actually being there, because once as the moon starts to eclipse the sun, you see weird things with shadows on the ground. Like all the shadows you see start to look like crescents of some sort, and there's no other time you experience that. And then once the total solar eclipse begins, totality, it only lasts a few minutes. Each eclipse is different. This one was about 2.5 minutes of totality. And so time is limited, time is precious.
Yeah.
I did have a pair of binoculars around my neck, and I wanted to see Mercury, because I hadn't seen the planet Mercury before, although I had tried like 5 times. And I knew where it was going to be in relation to the sun. That was one of my goals. I did not succeed in that. I was not able to see it. But just when the moon went in front of the sun, I was able to I felt like a fear that was irrational. Like I don't know why.
I felt the same thing. Like
Yeah.
really.
And like I knew everything that was going to happen. I had watched tons of videos about this, expecting it, but for some reason I was like, oh no, my body.
Yeah.
But then my intellect, my reason was able to tell my body, calm down. It's just an eclipse, but take advantage of it. And so, so I was able to calm myself down. But just feeling that awe and wonder in that moment, it felt like there was a hole in the sky, like where the sun was, and because the moon was blocking it out, and all around the horizon was like a sunset, and it was like I didn't expect that at all. But you can see that in the background, in the footage of the second camera.
Well, I'd love to actually share this video with everybody if you're cool with that.
Yeah, go ahead.
All right, so the sound should come through when I play it, and we're still on the stream, so we can comment, or you can ask me to pause at any moment. Here we go.
So this first one, this is the DSLR camera that is just focused on the sun. It has not been eclipsed yet. So the solar filter is on right now.
So what's the solar filter doing?
It is blocking out 99.99% of light that's coming from the sun. And then totality begins, and then I'm taking off the filter, and then now you can see the eclipse without any filter at all.
Wow, how about that? You know, I was in upstate South Carolina at the time, and it was near total. The visual is remarkably different here. Is this purple accurate as far as like what the eyeball would see, or is this from the camera?
No, I think that's just an effect of the camera. It's not super high quality, so yeah.
That is super nifty.
And the sun and moon are traveling in the sky, so that I could start with this in the lower left corner. I knew it was good, and then now it ended, and I had to put the filter back on, not to ruin the camera.
Right. Yeah. Wow. Okay.
And then, so this is the second part. Now we go back a couple minutes.
This is still partial.
It's still coming. Oh my god!
And this is right before it begins.
Okay.
And so the sheet is supposed to catch any shadow bands, like you see shadows waving. It's something that I was not able to see with the naked eye, but then I was able to see in this video. And so we had a group. I sped up the totality for that because you want to focus on right before and right after, and like kind of beginning and ending for this.
10 seconds.
You could see how the horizon changes.
Yes. Yeah. And what a beautiful setting! I mean, that's not too shabby either, right? You get to just go to a beautiful place, and watch an amazing, beautiful event.
Yeah, we climbed the hill in Weezer, Idaho.
Oh, holy cow!
That is very cool. Holy cow, as your companion said. That's very, very cool. So, at what point of your studies were you when you took that trip?
I had completed my first year of grad school at that point.
Okay, cool. And were your companions other students in?
Yeah, we had 2 other grad students there that were 4 years ahead of me. They have both gotten their PhDs and moved on. And my advisor was there, and one of my collaborators from the University of Maryland came with his wife, and he joined us for that. You know, wanted to be in the path of totality. Don't blame him.
Just that phrase, in the path of totality. Sorry.
Yeah. After this experience, it made me want to go around the world for every eclipse. Unfortunately, you know, it costs money to travel everywhere, but whenever I have an opportunity, I'd like to do that. Maybe even in my future, I'd like to build, or I don't know about building, but to go on ships out in the sea and navigate by the stars and chase eclipses. That sounds like my retirement dream to me right now. We'll see if that changes at all in the next couple of decades, but it sounds pretty nice at this point.
Yeah. Have you ever read Kon-Tiki?
No, I
Thor
haven't.
Heyerdahl? Yeah, he was a guy who studied Polynesian culture, and he wanted to prove something that a lot of people said was an impossibility, even though there was anthropological evidence for it, which was sailing across the Pacific in, the glorified rafts that the Polynesians would build. And so he did that. He went from Peru to, I forget where, but he sailed across the Pacific in a Polynesian style boat, navigating by the stars. And anyway, it's a cool book. It came out sometime in the 60s, I think.
Oh, cool. I'll have to find that.
Yeah. Well, let's talk about the calendar.
Sure.
So astronomy, calendar. I'd love to know, especially thinking of me as a high school student, someone taking your class, what would you be looking at with the calendar? And you said something interesting, off camera, which was there can be no such thing as a perfect calendar. So
That's right.
I'd love for you to talk about that as well.
Yeah. It's really interesting. Is just with Julius Caesar that we finally had a calendar. That some civilization finally had a calendar that was fixed to the seasons. Before that, many cultures used the moon for their months. We get the word month from moon, but it's not commensurate with the year. So the seasons then, according to their months, would drift through their calendar year. And so it doesn't, like, some years it's snowing in June, some years it's snowing in December. It doesn't make sense. But then with Julius Caesar, the Julian calendar, that was the first attempt, and it was pretty good. And nobody noticed that it was off for several centuries. And then it was in the Middle Ages that we realized, okay, the seasons are drifting, not by a lot, but we're some days off. And in Rome, they were able to build a meridian line in the Tower of the Winds in the Vatican. I've been there. Pretty cool.
I didn't realize that had been done.
Yeah, and 1582 was the year. So the study had been done a few years before that, but 1582 was the calendar change, the Gregorian calendar. We skipped 10 days, went from October 4th to October 15th overnight to regain like where we were supposed to be. Now, the reason why the church is concerned about the calendar is because at the Council of Nicaea in 325, it was determined that Easter should be celebrated on the first Sunday after the first full moon, after the vernal equinox, which is the first day of spring. So it matters when is the first day of spring. We want all Christians to celebrate Easter on the same day. We want to be united. So it matters because of that. So because of politics and different branches of Christianity at that time, not all countries moved over to the Gregorian calendar right away. England didn't move over till early 1750s. Russia moved over in 1917, pretty recently. And some of them still follow a different calendar. In fact, so with the new calendar, with the Gregorian calendar, there's a new rule for leap years. And it's one that most of us don't know because it doesn't affect our lifetimes. The Julian calendar, it was a leap year every 4 years. February 29th, every 4 years. But now there are exceptions since 1582. When the year ends in 00, it is not a leap year unless the other digits are a multiple of 4. So 1600, 16 is a multiple of 4. That was a leap year like normal. But 1700, 1800, and 1900 were not leap years. 2000 was a leap year because 20 is a multiple of 4. So in our lifetimes, we don't experience that exception. But that's what the new rule is. And this makes our calendar accurate to the day, at least to the year 2600. So that's pretty good. We might not be concerned with changing the calendar because it's not going to be bad in our lifetime. But whatever any leap year rule that we want to invent, we might try to find a better rule, exceptions to exceptions to exceptions. The Russians devised another calendar, the revised Julian calendar, it's going to become more accurate than the Gregorian calendar after the year 2600. But even that one is bound to become inaccurate at some point because of large-scale events that are happening in our solar system. The moon is receding from the Earth; it's going further away, and with it, it's stealing angular momentum from the Earth. So the Earth's spin is slowing down. Days are getting longer. We've added leap seconds onto our official time for the past several decades. It's only been, I think, 28 of them so far. So it's like, insignificant. But over the course of centuries and millennia, this is going to make a difference. Our days are going to get longer, and then the year will be a different number of days. So we have to be flexible and be able to adapt. So the calendar we have right now, it's good, but it's not permanent.
My mind is being blown right now, for two reasons. One, I'm finding out new and cool information, but then that experience you have when you are realizing there was a gap in your knowledge that you didn't even know was there. Right? I've come to peace, come to terms with a lot of the vast fields of ignorance, but I thought I had a handle on the leap year, and then to discover there's so much more going on is pretty delightful. In fact, Samuel here is experiencing the same disjuncture that I am. Wait, days are getting longer. So actually, could you kind of go over that one more time, or a little more in depth for us? That was a pretty awesome moment.
Sure. It's going to take a long time beyond our lifetimes, and so we're not going to notice much of an effect. And right now, they're just tweaking days by adding leap seconds every June 30th and December 31st. The U.S. Naval Observatory decides, are we going to add a leap second or not? And so that's just their way of tweaking it for now. But like thousands of years or millions of years in the future, the day won't be 24 hours anymore. And so it wouldn't make sense to just keep on adding leap seconds forever. Like it'll be very different. But this is the far future.
Yeah. And in theory, kind of moving away from this a little bit, but back to managing leap years. Since we can't ever build anything that's perfect, at some point people are going to be resetting, as in the great reset of the Gregorian calendar launch. Mm-hmm. Right, this is going to have to happen. Mm-hmm. That is absolutely fascinating.
I also wonder if we want to adopt some new system, if we start to colonize Mars, because Martian days are different from Earth days.
Right.
And they're probably not going to want to just go by Earth days forever.
Yeah. So my assumption in thinking about stuff like that is that they would just have to be two different systems, mm-hmm. And you would just kind of work with that. But have people actually thought about integration and what that might look like, or how communication between the two systems? Like someone somewhere has sat down and worked on this, right?
Perhaps,
but no one you know of.
No. There's a 20. Well, it depends on the positions between Mars and Earth, but let's just say roughly 20-minute delay in any communication between Mars and Earth. So it takes 20 minutes to relay any message by electromagnetism between Mars and Earth. So there can't really be any live streams with people on Earth and Mars. I've thought about some sort of liturgical calendar synchronization between Earth and Mars, because the Mars year is almost 2 Earth years, but not quite, if you want to use Mars days. So maybe they would do something in order to celebrate Easter with those who celebrate Easter on Earth, they would celebrate it twice every Mars year, and then you sort of make something around that. It's just a thought.
That's actually quite a thought. It's an interesting. I mean, you surely have dabbled with the idea of writing some science fiction. Surely, given the places you've allowed your mind to wander over the years. Do you take Elon Musk's Mars rhetoric seriously?
I think that he's really motivated to go there, and I think it would be really cool. I don't know. I don't know if I can like trust everything that he does, that he tries to pull. But I think that he is pushing mankind forward in several ways. We'll have to see if all of them or some of them are successful. But certainly colonizing Mars would be the biggest thing if he's able to do that. I don't think his timeline is as realistic as it could be, although I'm hopeful that it's like that. I just don't expect it to go according to his plan exactly.
I am curious to know, though, if you expect to see Mars colonized within your lifetime.
I think we'll at least have humans set foot on Mars in our lifetime. I don't know if it'll be the sort of trip where they come back or they stay there.
So here's a question that wanders a little further afield, but what would motivate, I mean, I'm not sure what motivates Elon Musk. Being awesome seems to be one of them. I mean, he builds flamethrowers.
Yeah.
But what would motivate our societies to want to colonize Mars?
What he talks about being the biggest motivation is to have a backup Earth. So just in case something bad happens to Earth, we have people on another planet. But then when you use that argument, there are always people who say, well, why we should just focus on saving Earth rather than trying to start up on a planet that's even harder to survive. But I think that trying to get to Mars would help us develop new technology anyway that would help us on Earth. So I don't think it's something where you can only choose one.
So speaking of planets, I hear conflicting reports. Is Pluto a planet or not? And why? Please.
Good question. And I am not going to make everyone in the live stream happy, but Pluto is not a planet.
Boom. Okay. I was going to say boom regardless of what you said, but yeah. Okay, so not a planet. All right, why?
So it's because we have a better understanding of the solar system now than we did when Pluto was discovered. That's the basic reason. And I'm going to go into more depth in 1 second. So in 1801, well, 1800, let's back up one extra year. What we understood of the solar system was that it was Sun at the center. By then, was pretty established. Mercury, Venus, Earth, Mars, Jupiter, Saturn. Uranus had just been discovered by William Herschel. I believe in the 1780s. And then that was it. Then in 1801, so there was this law, someone trying to figure out a mathematical relation between the distances of all the planets, and they seemed to think that we were missing a planet between Mars and Jupiter. Well, it turns out in 1801, Giuseppe Piazzi, who was a Jesuit priest, he discovered an object, Ceres, in between Mars and Jupiter, like right where it was sort of predicted. And it was definitely smaller than any of the other planets, but it was considered a planet because it was the next new object discovered. In the years following, many objects were discovered sharing the same orbit with Ceres, and this is the asteroid belt. But at first, these were all considered planets. In the 1840s, we realized Uranus was not behaving the way we expected it to with Newton's laws. So it was guessed there must be some planet beyond Uranus that is tugging on it, that's affecting the orbit of Uranus. And a couple of different mathematicians in Europe different countries tried to race to calculate where this other planet should be. They sent their results to different astronomers in countries in competition, and Neptune was discovered in 1844. I believe it was the French discoverer, Leverrier, who won the race.
Okay.
Although, if you talk to someone from England, they're probably not going to agree with that.
Yeah, I get that. Brazilians claim to have invented the airplane.
Yes.
And they have a whole narrative about it. Yep. Okay.
I've heard that one before too. Yeah. But either way, Neptune was discovered, and then we decided, okay, well, this is really a big planet, similar in size to Uranus, and these other objects that we've been discovering for the past few decades in the 1800s through the 1840s, we shouldn't really call them planets. We should just call them asteroids. And so that's what they did. Now, Ceres is the largest asteroid. It makes up 1/3 of the mass of the asteroid belt. So, and it's round because of its own gravity. So that is something significant, and it was considered a planet for 40 something years. Now, when we go through several decades later, astronomers were saying, well, now Neptune's not behaving in its orbit the way we expect it to. Maybe there's something beyond that planet that is tugging on it. And it should be right around here. And then Clyde Tombaugh in 1930 looked and was able to discover Pluto. Now, his discovery of Pluto was a little bit lucky, how he just looked in the right spot, because Pluto's really a lot less massive, and it isn't really tugging on Neptune in the way that it was thought at the time. But astronomers thought Pluto's tugging on Neptune. It must be about just as massive as Neptune. So it's a planet. So we just didn't understand how big it was, how small it was at the time. Now, it was the last thing discovered out there for several decades. And so since we didn't start discovering other objects in the belt that's out there, the Kuiper belt, until the 1990s, that's why Pluto was considered a planet for so many years. Then in the 90s, we started discovering there are thousands of other objects out there, some sharing the same orbit as Pluto. Pluto is in a resonance with Neptune. Neptune orbits 3 times for every 2 times Pluto orbits, so that whenever Pluto crosses over the orbit of Neptune, Neptune's never nearby. That's why Pluto is so stable. There are lots of objects in other resonances with Neptune as well. And it just makes sense to classify those as another belt, the Kuiper belt. And so we have that understanding of our solar system today. Go ahead.
It's interesting to even just to hear that in relatively recent history, other objects have changed status and lost their planet status, because I think so many of us took it personally when it was first announced. And like it felt like it was beyond how I had to learn this in grade school, and now you're just changing things on me. I think people had affection for Pluto. But to hear that, I didn't know, for example, that Ceres had its status changed. I am curious, like how so. You see, so the Pluto was found because of there was an effect being seen on, was it Neptune that you said?
Yeah.
Right.
It turns out it wasn't. It was just sort of a miscalculation.
Okay, that was my question. Okay. So there wasn't some sort of convergence of different forces that were creating this effect, and we didn't understand it. It was bad math.
Yes.
Okay. Well, that's simple enough. It does. So mythologies and stories, and even like the Justice League, there's an association of the heroes, the superheroes, with the planets. Aquaman gets Neptune, obviously, and Superman gets Jupiter. My favorite superhero's planet is Pluto. Batman gets Pluto, which makes total sense. But now it's just sort of lame. Like, it's just, it's
Batman's my favorite too.
Yeah, so that's a bummer. I don't know if it bums you out, but I'm glad I'm glad we're together on the Batman thing.
Yeah, Pluto, even though Pluto is not a planet, it's still an object worthy of investigation. We had the New Horizons probe that flew by Pluto in 2016 and took amazing pictures of Pluto for the first time. It was the closest we had ever seen. And it made us realize Pluto's surface geology is active like Earth. And that's something we didn't expect way out there. We thought, oh, it's too cold. But no, there are some internal processes that are going on, as we can see with its surface. So we're definitely going to go back there and study it more at some point in the future. There are other objects out there we want to research as well. So whenever we make a mission to go out into the outer solar system, it takes years and years to get there. That the New Horizons probe took 10 years to get to Pluto from being launched on Earth. So it takes a lot of thought first to design and build a project, and then more time for it to get there. So we want to research so many things, but we sort of have to decide like what's the most important right now. Mm-hmm. And I'm sure Pluto will get more science within the next several decades. But
I appreciate your comforting words. Like they're there, Joffrey. Yeah. Pluto's gonna get some attention.
Pluto found its real family, so it's not.
You know what? That's a beautiful way of putting it. Yeah. Okay. Thank you. That's actually a great comfort. And if I ever run into someone who is still dealing with that emotionally, I will say Pluto found its real family.
Yes.
So y'all anyone who's watching, you're very welcome to pose any questions right now. We can definitely put Mr. Ahern on the spot. But I actually have a question for you. Well, my daughter just spent a bundle for babysitting money, like $400 on a telescope. Which, that's a lot of money for her. That's not a lot of money for a telescope. But, if she goes out into the backyard with that thing to look at stuff, what's cool stuff to look at?
It depends on the season. Mm-hmm. But in every season, there's cool stuff to look at. So the first thing definitely is the moon. And you might think, oh, I've already seen the moon. But have you seen it through a telescope? Have you seen it close up? Have you seen the mountains and the craters? It's just mind-blowing. And you can even look at it with binoculars and be blown away. So the moon first, any planet, but especially Jupiter and Saturn. Those are my favorite two planets to look at through a telescope. With Jupiter, you get to see the 4 Galilean moons, the ones Galileo saw in 1609, Io, Europa, Ganymede, and Callisto. They're all in the same plane, and they transit in front of Jupiter and are occulted behind Jupiter on a time scale of days, because their orbits are so quick. And so it's pretty neat to catch one of those events. But just like seeing them all in the plane, it looks majestic. Then there's Saturn with its rings, and that's really cool. One time I was showing someone Saturn through a telescope, and they said, I think you just put a sticker on the end of the telescope. That's not actually Saturn I'm looking at, because it kind of looks fake. But no, that's what it looks like.
That's Venus, cool.
With Venus, you can try to catch the phases of Venus, like the crescent and gibbous phases. That's not something that I have seen in too much detail, because back when I tried to, I wasn't using the right kind of telescope for it. But you only, with Venus and Mercury, you only have a small time window, shortly after sunset or shortly before sunrise, to try to see those. Venus is really bright. Jupiter is also really bright. You can look at Mars, but just with a backyard telescope, Mars isn't too exciting. Like, it's Mars, but you can't see all the details unless you get a bigger one. So that's planets. Then there are nebulae to look at. The Orion Nebula is really cool. But that's more in the winter. Sort of like where the Sword of Orion is. It's kind of easy to find. There's the Ring Nebula in the summer to find near Vega. So there are 3 bright stars sort of near the zenith in the sky in the summer. We call them the summer triangle. Vega, Deneb, and Altair, those three stars. And so those help you orient you to find any constellations in the summer sky. In the winter sky or any other time of the year, we have the pole star. And I expect most people might have learned the Big Dipper and how to find the pole star from there. If not, it's easy to go over quickly as well. How the two stars on the end of the Big Dipper point towards Polaris, the pole star, which is the pole star for now during our lifetime. It's not always going to be at the pole, but it's good to be able to have some references in the sky. Maybe learn the constellations first, and then you can orient yourself to find these other objects. But some of those nebulae are cool. There are globular clusters to look at, which is just like a lot of stars packed in a small area. My favorite is M13, which is in Orion, sort of in the summer sky. And you've pulled up a map of the night sky there. Is that? Oh, that's with Stellarium.
Yeah, is this any good?
Yes, Stellarium is a great program. I have that myself, and there are lots of features you can have with tinkering around there. You can see the constellations.
So this is from Moscow, Idaho.
Mm-hmm.
And this is just their online map, which is much more limited. But so this is a resource that you enjoy and use.
Yes. A lot of the night sky. I learned when I was in high school, in my senior year of high school. We had in one of the classrooms at the school I was at in New Hampshire, they had constellation maps up on the wall in one of the classrooms. And whenever I walked in or left, I tried to learn what's the next constellation I'm gonna try to find. And we had different buildings, so I'd always be out at night, at least walking from one place to another, and I was able to learn the entire northern hemisphere sky that way in one year. So that was really helpful for me going forward to try to find different objects.
Yeah, for sure. Yeah, this is such a cool website. And I was interacting with someone in New Mexico who works with the night sky, and he was using a software, and I can't remember the name of it now, but it was showing the different constellations, but you could select the culture, and wow. it would show their constellations, and they were absolutely fascinating. And some cultures that were like, for example, some Native American groups in South America, there were like 5, and that was it.
Wow!
But it was really fascinating how many things that were in common and things you would not necessarily think everybody would see, which I think when we think about the history of humanity and the history of the people of God and the Bible, that ends up being pretty fascinating stuff. I wonder if you have any comments about how the stars and constellations are treated in Scripture, and maybe how we should interact with all of that.
That's a good question. I know there are some passages, especially in Job, that refer to specific constellations or parts in the parts of constellations. I plan to look more in depth in my course, and it's something that I'll have to go over before I want to go through that. But one interesting thing is with the Star of Bethlehem. We always wonder, what was it that the Magi saw and led them to Bethlehem, and that in Stellarium or Starry Night or some other program, you can go back in time and look to try to figure out what it was. I've done that myself, and there was a conjunction between Jupiter and Venus, I believe, in the year 2 BC, something like that, June 17th. That seems like if somebody saw that in the sky, they would say, hey, there's something going on, perhaps, if they're trying to interpret. So that definitely could be the event. We can't determine with 100% certainty what it was, but that's a natural event. It could have been a supernatural thing.
Yeah, right.
We don't, but we would have no way of figuring that out now.
That's still pretty cool to, to try to just go through those exercises.
Yeah.
People will often try to do that sort of exercise to disprove Scripture, but when you accepting the Word of God, by faith that it's the revealed Word of God. It could be a natural event. It could be supernatural. We don't know. And wouldn't it be nifty if we found some sort of, because ultimately everything natural is also supernatural. God is sustaining everything. Every movement is not only God ordained, but God acted. Right. So even categories of supernatural become quite fuzzy. And it's a nifty thought to think, wow, God made an amazing nova-like thing, I don't know, happen so that imagine I could see it. But it's just as amazing to think God spun the universe in such a way that it would all come together at that moment.
Yeah. And another thing that is just really cool, that it's one thing that makes me think this conjunction between Jupiter and Venus. Well, Jupiter, the king of the gods for the Romans, Venus, the fertility goddess. So it's like birth of a king. It happened near the star called Regulus, which means little king in Latin, which is in the constellation Leo, the lion. And so there are connections between that and like connected to the Lion of Judah. And so all of those things, it's like, sure, a few different cultures sort of mixed together, but it seems like, hey, maybe that was what God wanted to do.
Yeah, for sure. That's absolutely fascinating stuff. So that Stellarium website that we were showing everybody, this is their web version, which is pretty limited, but there's the software that can be downloaded. Are there any other resources that you would recommend to students, enthusiasts?
There are so many different resources. I would start with Stellarium. It's free. At least it was when I downloaded it. It probably still is. And there's a lot you can get for free. But there's a lot more you can get when you want to start investing some money into it too. Yeah, I don't think I have a specific thing to say. I was wondering though, do you know, because you were talking earlier about your daughter's new telescope, what kind of telescope she had?
I don't know. And I was actually thinking, as you were describing all the stuff, I was thinking how sad it was that I don't know, because I was wondering how much of what you were saying she'd be able to find. Maybe she'll have to sign up for your class this fall. So I'd actually love to close our stream, and I'd love for you to just tell us why a high school student should sign up for your class.
Well, first of all, I did some online searching, and I could not find any high school astronomy course that was able to teach from the perspective, going through the history, including philosophy and Christian theology, along with the scientific approach. I'm in my fourth year of the Ph.D. program. I do research in astrophysics, solar system dynamics, to be more specific, and I have a background in philosophy as well. I think it would be hard to find someone who has come from so many different angles and can help you understand astronomy, where all these parts of human knowledge meet, as well as I am going to try to do.
Okay, cool. Yeah, I'm reading that description, and even as we talked early on in the stream about your ambition to be making this a philosophical course. I mean, we are studying natural philosophy after all.
Yes.
Well, hey, I really appreciate you coming on. I'm excited about this course, and I'm excited to see what my daughter Renata can find in the night sky. Thanks for coming on.
Thanks for having me.
And actually, I should have mentioned to you earlier, feel free to stay on. Just stay on while I sign off, and we'll be able to chat at the end. So long, everybody. Thank you.
All right. Bye.